Okay, hey guys. So this is going to be about finding points. 1 second. Finding points of intersection. Points of intersection. So given two straight lines, or rather given 4 points, we can find two straight lines, line 1 and line 2. Um, and given that they're not the same steepness, they're going to intersect, right? Given that something's not the same steepness, they're going to intersect. AKA, they're not parallel, so they'll intersect. Okay, so our goal here is to find this point right here. Okay, so let's start slow and steady. Let's put down all the data we know about the point. So where's point A? Is that 2, 2, right? 2 comma 2. You notice the scale goes up by 2s, not 1, so just be careful of that. We know B is at um, 6 comma 6. That's nice. C is at 8 comma 0 because it's 8 across 0 up, and D is at 2 comma 8, right? So we've got all our points lined up. So we know the first line, so let's start with line 1. We know the first line connects which 2 points? A and B, right? So we've got to connect A and B. So how do we do that? Well, we know it's a straight line. We're running through our whole straight line procedure. So it's y equals mx plus b. Start there. These are constant. These two are unknown constants. We've got to find them. M is the gradient, which is the steepness, and you find that by rise over run. So you pick a point. We'll do A because it's the first letter. We'll go A to B. So how far do we rise from A to B? Well, its height is 2, and B's height is 6. So we rise 4, right? So its rise is 4. Now you can do that off the graph or with these two numbers that we have here. Okay, how far is it running? Again, you go from A. You can't switch halfway. Uh, yeah, you can't switch halfway in finding the gradient. You can't switch where you start. It must be from the same point. So it's 2 across, and B is 6 across. So again, it runs from 2 to 6, right? 2 to 6. So you get a distance of 4, which gives you a gradient of 1. So nice and easy. So now we have y equals x plus b. We're going to not put the 1 in. We've got to find the y-intercept. Nice. This graph gives us the y-intercept. It goes through 0. So we can assume that b equals 0. If we wanted to test that, how would we do it? We'd say if a point lies on the line, it'll satisfy the equation, right? So we know 2 points that lie on this first line. We know A lies on the line and B lies on the line. So we could, let's just pick A because it's a smaller number, and we just sub it in. So we get 2 for Y, because remember that's Y and that's X. So 2 for Y equals 2 for X plus B. So we get 2 equals 2 plus something. So how do you solve for B? Well, you move the 2 over and you get B equals 0, right? So you can do that graphically or algebraically. It's best to know both ways depending on the situation. So anyways, that first line is just y equals x because b is 0 and m is 1. So that's our first line. Okay, let's move over here. We'll do line 2 in green or something. So line 2 now. Maybe I'll underline this. Line 2. Again, we start with y equals mx plus b. How do we find the gradient? Let's always start with the gradient. Well, 2 lines with 2 dots we're connecting C and D, right? These 2 points. So I'm going to pick C this time just for no reason. We said you could pick either one, remember? So we'll pick C. And we need to figure out how far we're rising to get from C to D. Well, we're going to rise from 0 height to 8 height, right? So we're going to rise up 8 from C to D. Positive, right? Um, Now, how far are we running? Again, from C to D. We're going from 8, because it's got an 8 distance, x distance, so we can look at these coordinates, or this coordinate, and it has an x distance of 8. What's the x coordinate of D? Well, it's 2, or you can see here it's 2. So how do we get from 8 to 2? Sounds like 6, but it's negative 6, right? It's negative 6, because to get from C to D, we've got to go back from 8 to 2. You got to go back 6. So we can simplify this a little. We can make it negative 4 over 3. I'm going to bring the negative out the front, and we realize both these are divisible by 2, so we just simplify. So now we know that our equation is negative 4 on 3x. So we finally have a gradient that's it's not 1, which makes it a little more interesting to look at. Okay, now we need to find b. How do we do that? Well, last time we could see it. This one's not so clear exactly where it is, so we probably shouldn't guess from the graph. We need to find the value. So we'll do for point lies on the line, it'll satisfy the equation. So we're going to pick a point that we know lies on the line, so we could use D or C. I'm going to use C because it has a nice little 0, so hopefully something will it'll be less complicated with a 0. So we're going to sub c, but you can use any point that lies on the line, sub c into the equation, right? Because we know it lies on the line, so therefore it will satisfy the equation. So what is c? It's got a y coordinate of 0. It's got an x coordinate of 8, so we're going to have negative 4 on 3 times 8 plus b, right? So let's just try to simplify that. So how do you times fractions? Oh, sorry, it's not a fraction just yet, but any whole number can be divided, in quotation marks, divided by 1, right? So technically this is over 1. So you have, and how do you times fractions? You do, you go across the top and across the bottom, times across the top and times across the bottom. So you get negative 4 times 8, which is negative 32, and 3 times the invisible 1 here, so you just get 3 plus b equals 0. And then how do we solve for b? You just move this to the other side. It's currently negative, so I'm going to add 32 and 3 to both sides. So you end up with 32 and 3 equals b. All right, so now you have your b. Obviously, you shouldn't have done that from the graph because you can't do it from the graph. It looks like it could be 11, roughly. If this was 33 on 3, it would be 11, so it's probably close to 11, which is what the graph seems to point out. But it's not exactly 11, so you got to be careful there. So you end up with y equals negative 4 on 3 x plus 32 on 3. Okay, so that was the whole setup of the question. We had to find the equations, and they might break this question down into, hey, here's part A, find the equation of the first line, then part B, find the equation of the second line, and then part C, find the point of intersection, find where they connect. Remember, we're trying to find this point here. Okay, so now that we've hopefully done all that properly, yep, we can tackle the actual point of intersection part. Okay, so wait, I think that's a bit of stuff I forgot to write about. Okay, so how do we do that? We have two equations. We've got equation 1 and equation 2. I didn't box this, but I'll box it now. Right, we've got two equations. We need to find where they intersect. Okay, let's think about this point. It's a really easy method, and we're going to follow it, but I just want to give you a bit of understanding about the idea. So at this point, what do we know about this point that's true on both lines? We know that the x coordinate and the y coordinate, this point is going to be, let's call it e, because it's the next available letter, and it's going to have an x and y coordinate, right? Its x and y coordinate, whether or not it's on the first line or if it's on the second line, it's going to have the same coordinates. It doesn't care which line it's on, which line you pretend that it's on. It's just there at some point, and these lines happen to go through it. Okay, so these x and y values are going to be true for both of these equations, right? So the idea around it is, where does this graph have the same height or the same y value or x value as this graph, isn't it? It's where is the y value on this graph equal to the y value on this graph. So we want to know, maybe we should put a little 1 and a 2 here. We want to know where y1 equals y2, right? Because if we know where, so if we look at, like, let's say here, at this x value, at an x value of 1, we know that the height of the first line is 1 and the height of the second line is something around 9. Okay, so those heights aren't the same. What if we move to like 3, x value of 3, which is in between 2 and 4, right? Then the height of this line is also 3, and the height of this line is, I don't know, something around 6.5 or something like that. So those aren't the same heights, so that's not good. And as we get closer and closer to the point that we're interested in, we'll notice, oh, at this point, whatever x value this is, looks to be something around 4.5, we will have the exact same heights on the first graph and on the second graph, right? They'll both have the same height. So really what we're interested in is where the height of the first line equals the height of the second line, okay? And how can we kind of replace this? Well, what is y1? y1 is just x from the first equation. And what is y2? y2 is just all of this. So we just put that in there. And what this does is it gives us an equation with one letter, which we can solve. If you look here, you can't really solve for it. It looks like it's one letter, but these are really different things. y1 and y2, both of them are y, but they're different heights. They describe different heights. They both describe height, but different heights. Whereas this is a singular x, so you have one unknown and one equation. So we just need to solve as you do with any algebraic expression. So first thing we should do is collect like terms. So I'm going to move all of this to the left-hand side. So you can think of this as just a number, right? It's really a decimal. It's 1.3333. And how would you move something that, let's just say it's 2 for now. Let's just pretend it's 2. If it was negative 2x, how would I move it to the other side? I'd add 2x, right? So I'd end up with 3x over here. We're going to do the same thing. We're going to add 4 on 3x to this side. So we're going to have x plus 4 on 3x, and it's no longer going to be on that side, right? It'll cancel out. So you just have 32 on 3. Now we add this up, so you got to make a common denominator, which is 3, and whatever you do to the bottom, you do to the top. So you get 3x plus 4x, which is 7x on 3 equals 32 on 3. Now, if the 3 and the 3's are the same, because we can do it another way. So if we want to get rid of the 3, we can multiply by 3 on both sides. So this will cancel here, and this will cancel here. So then you have 7x equals 32. And then you want to solve for x, so you get x equals 32 on 7 by dividing by 7 on both sides. And so you get an x-coordinate. This x-coordinate is the ex coordinate. Okay, well, we haven't found the whole point, have we? We need to solve for y. So this is simultaneous equations, right? Now we just need to back sub back into either of the equations, because again, given the x value for either of the equations, the y value is going to be the same. So it doesn't matter which one we sub into. This one obviously is clearly more complicated. This one's and this one's really, really simple. So we're just going to sub it into here. So if x is 32 on 7, then y equals 32 on 7 as well. So I'll write here sub into equation 1. That's just what we're doing. You don't have to sub into the first equation. You get y equals 32 on x, on 7, sorry. And so therefore your E is 32 on 7, 32 on 7. Okay, which is, I don't know, something over 4, just under 4.5, which is what we said, right? Roughly around 4.5, but not exactly. Cool. Okay, so that's how you'd find a point of intersection the whole way through. You'd have to find, given some points, they wouldn't have to have given you a graph, but it's nice to visualize it. They could have given you the points and said line 1 connects A and B, line 2 connects C and D, and then you'd have to find these two equations using y equals mx plus b. Then you'd have to solve for the point of intersections. And the way we do that is through simultaneous equations, which I really briefly did over here with very little explanation. But if you want more information, you can go to the other video that focuses on simultaneous equations. Okay.